Hey, so today we're going to finish up the scientific revolution. And so going to do a couple things, finish up notes, um, and then we'll do a little bit of a graphic organizer at the end of class. So first off, let's kind of go over those bell work questions that you have hopefully answered on that little sheet. Those go in the basket. So what are your thinkers, or who are your thinkers that are going to develop the scientific method? Well, the two guys who kind of like are explicitly credited with it are going to be Sir Francis Bacon and Rene Descartes. That's not to say that guys like Galileo are not using it. That's not to say that your other thinkers are not using kind of a uniform way to study and to perform experiments. But Bacon and Descartes are kind of like, well, let's combine these two forms of reasoning, or out of their two forms of reasoning, the way they research, that's going to be what creates what's a very modern scientific method and what's a very uniform way to study things. How are Vesalius and Paracelsus going to advance science, advance medicine? Well, for Paracelsus, remember, he's like, maybe, just maybe, the whole lack of health or the reason somebody's sick isn't due to some sort of humoral imbalance, so you don't have too much bile or blood, but maybe it's because of a chemical imbalance. And so if it's a chemical imbalance in Paracelsus's mind, you could treat it with some sort of chemical drugs. And so he's the first guy to kind of look at, well, why are we unhealthy? One, and two, how do we treat that properly? So he doesn't really see, I guess, the point in, like, bloodletting, throwing on some leeches. He's like, got to be a better way. So he's going to be experimenting a lot in alchemy and kind of chemistry, and experimenting with what works for this. Vesalius, on the other hand, he kind of gives us a more accurate way of looking at the human body, kind of the most accurate way we've had kind of since Da Vinci and his drawings. So Vesalius, remember, he is doing the autopsies on cadavers, most of which are criminals, if you don't remember. And he's creating these very intricate drawings of the inside of the human body, of muscles, of organs, the skeleton. And I mean, these are going to be invaluable for what we are doing with the body and how we are treating it, but how we're viewing it, what's inside, not just these like four, I don't know, big organs with these four different humors, but a whole lot more that matters. And finally, what is Kopp's bring kids great big donuts? Now, that's kind of a way to just remember your scientific revolutionary thinkers. So, Kopp's Copernicus, bring Brahe, kids, Kepler, great, Galileo, big, Bacon, donuts, Descartes, now Newton. If you can remember the Kopp's bring kids great big donuts now, you can at least think about, okay, who are my guys? So you can have like a C, okay, I know Copernicus. My B's, Brahe's a little bit harder to remember than Bacon, but remember, he's the guy with, the huge observatory. I was going to say observatory, that would have been weird. This huge observatory, Kepler kind of building on things, planetary motion, right? So I'd say they're probably the harder guys to remember, because they aren't this big name, especially Brahe. But moving along, so remember, Monday and Tuesday we'll kind of do a DBQ workshop. Very much recommend you looking at that DBQ beforehand, looking at those documents, reading those on Classroom beforehand. They're very short. They're like little clips of the documents. So that'll do nothing but help you on Monday and help you on Tuesday. On Wednesday, remember, we're going to have an open note quiz on the scientific revolution. Reading guides, need to have those turned in on Classroom by midnight tonight. All right, so you've got to, if you're writing it out, you need to take a picture, turn it in that way, and attach it. It's Isaac Newton. Calculus, I feel like, can be either like really good or really bad, but you all have Isaac Newton to thank for it. I don't think anybody's going to be taking it this year, but when you do, it's all him. All right, so moving along. So remember yesterday we looked at Bacon and his inductive method, which that's kind of going from specific to general, right? You're looking at very specific conclusions and kind of setting them in a general way, or like pulling them back in a general way and making a general conclusion. He very much believed in finding the kind of problem or observing, creating a question or hypothesis, and actually performing the experiment, analyzing the data. So very much like a modern scientific method. Descartes, where he uses deductive reasoning, so he goes from general to very specific. So a general kind of idea to a very specific conclusion. Facts, facts, facts for him. Those are so important. And questioning. You have this logical step-by-step sequence that involves answering the questions that need to be answered. And remember, he's also the guy who believes in, or kind of comes up with, Cartesian duality or dualism. And all that is saying there's spirit, there's like material. And spirit, you can't experiment on, right? You can't experiment on the intangible stuff of the world, or maybe not of the world. So you have to use logic, right? You have to use reasoning, and you have to follow those steps. You have to answer those questions along the way. Whereas the material, you can use that experimental method. You can go through, you can observe, you can hypothesize, you can experiment, analyze data, come to a conclusion. So that's just saying there's two kind of separate things at bat that you can experiment on. He's kind of smart enough to realize, like, we can't do the scientific method on, let's say the existence of God. Can't do that. That's actually is something that Descartes will use. He uses Cartesian duality. He used this like logical step to, at the time, because he is a good Christian, like pretty much everybody else in Europe. So at the time he uses Cartesian duality, he uses that logic sequence to, in his belief, right, prove God. So I think the church would have definitely been more accepting of him and of that, if nothing else of him. That's our Cops Ring Kids Great Big Donuts Now! Gosh, that's dumb, but I think you'll remember it because it is so dumb. Remember, for kind of the way we did look at the human body, it's very much, based on Galen's thoughts, this old Roman physician, and we've got the balance of the four humors, the blood, phlegm, black bile, yellow bile. And you start to see guys maybe say, I think that's wrong. Like Paracelsus is like, yeah, I don't think it's humoral imbalances. I think it's another type of imbalance, right? And Vesalius is just like, hey, let's look at the body the correct way. And so he's going to do a lot of studying. Like, there he is right there. He looks like, and this is not to be like a bad thing, in this picture he looks kind of like a little person. I think because his body is like sitting down, that he's working on. So you see some of his bodies and some of his drawings that he's going to make. So whether it's, muscles all over the body, or just, skeleton, you can see different parts going on. William Harvey is kind of where we're starting up today. So William Harvey is going to say, hey, this heart thing that we have that Vesalius has been drawing out, like, it does something. It does a job. So he says, the heart pumps blood throughout the body. That blood goes through the body, through veins, through arteries. A lot of times our older physicians and thinkers kind of had a wrong idea of, like, what were the organs for? So the heart didn't seem like that important of a thing. Obviously, it was a major organ. They knew that. They knew everybody had a heart, but the extent of its importance, not so much. Kind of similar with like the brain. They used to think that the only thing the brain did, only thing, guys, was regulate body temperature. And that was it. Like, think about that's the organ that kind of does the most. Like, even when you don't realize it's doing something, anything you do, any action, speaking, breathing, blinking, moving at all, whatever, that's your brain telling your body to do that, right? So kind of off on that. They definitely didn't realize the significance of the heart as well. So that was kind of something that's like, well, little far gone, guys, little far gone. You can see he's got, in that figure, he's got the arm like kind of tied up, almost like you're about to like give some sort of blood. You're trying to find a vein, and somebody's like squeezing on a bar, make their veins kind of more evident. And so he'd show like, hey, it's blood going through there. When they're squeezing, that's blood circulating. And that's what the heart is doing. It's pumping the blood. It's doing kind of the job. It's the engine of the body, kind of taking care of everything. This guy right here, Anton van Leeuwenhoek. So you say the W with a V. Hook is just kind of the end, not like Hoek. And then just lay instead of Lee. Leeuwenhoek. I guess you can say it that way. Just don't like be serious when you say it that way, because then everybody will think you're joking. It'll go over well. So Leeuwenhoek, he's going to be a guy who kind of builds on the microscope. So remember we said like the microscope is kind of one of those random tools that resulted in like exploration and making better navigational tools. So Leeuwenhoek's like, how can I improve this? Because I know Will in fourth period was asking, like, at least with telescopes, how far can they see? I mean, a decent distance for what time period it is. They're very helpful for the time period, especially if it's just a basic one on the ocean. Of course, like Brahe, Kepler's, Galileo, much more powerful. But kind of the same is true with microscopes. Like, first ones are going to be pretty crappy, but they lend way and they kind of tell us and show us like they can be better and we can see a whole lot more. And so some of the things that he's going to see with his microscopes that he develops, bacteria. So bacteria moving around, yeast plants, living organisms in a drop of water. So, when you magnify a drop of water, you're not just going to see like H2O molecules. There's always, kind of something in there. Probably less true today, but I mean, you're not going to have some nice purified water in 1600s, 1700s, more than likely, or super purified water as we can get it today. And the circulation of blood in capillaries. And so that's going to be, I think, a big thing, y'all, in the sense of like, okay, William Harvey said, we've got these veins, we've got these arteries, that's what's circulating blood throughout our body, that's what's kind of keeping us alive. And Leeuwenhoek kind of goes further. He's like, it's not just arteries and veins that these, the blood's being pumped through. It goes even smaller and even smaller and even smaller. And so if he's seeing this stuff, kind of imagine the possibilities for anyone in science and like literally how exciting this has to be for anyone in science. The fact that he's finding all this new stuff and it's like, oh, whoa. If he's seeing this, what's even further down? If we can see living organisms in a drop of water, well, is there any way that we can actually see just those organisms. What do they look like? So a pretty awesome thing, I think. And that is, I think, something cool to look at when you do have, like I remember like biology labs in college, like when you do actually have like really powerful microscopes, and you are looking at certain things and you're looking at stuff move around, or you're looking at, maybe bacteria that you've grown, or like E. coli that you've grown. It's a very interesting sight to see. And so, I mean, I think even minds who are like not all about science are like, oh, that's cool. Something's going on there that I wouldn't have been able to otherwise see. Definitely wouldn't have been able to see with the human eye. What we're going to see is as the scientific revolution revs up, as it becomes kind of more accepted by the church, you're going to start to see governments, state monarchs, kind of encouraging scientific inquiry. And it's kind of the same reason that we said our patrons of the art, like kind of during the Renaissance, kind of the same reason that they would be funding art projects. The governments, monarchs are going to fund scientific inquiry, because if something goes right, our state just got more powerful. We can claim that, we're better than everybody else because our guy invented this or discovered this, whatever else. So it was a way to build up state. And what we're going to start seeing is countries like England. England's, remember we circled that. We said that's the center for a really long time of the scientific revolution. If we were going to pick one city as a center, that would be it. England is going to be one of the countries kind of leading the way with some of our other countries, France, Prussia, Russia, who are deciding the best case scenario is actually to create universities, to create scientific communities, societies, to make sure we build up science, and to make sure we better just Europe in general, right? We want our continent as a whole to be better than everywhere and anywhere else in the world. That wasn't going to be hard for the Europeans to do, in the sense that they already greatly believed that, so they didn't really need much more like encouragement. So they were already like, yeah, we're pretty awesome, we're pretty cool, and they make these like royal societies and these scientific societies, and they're like, yep, nobody else in the world has that, right? When in reality, that's probably incorrect. Probably the Ottoman Empire and East Asia would have had some form of like scientific community society. We will see that the Royal Society, probably the most famous, probably the most well-known. If you're a member of the Royal Society, it kind of meant you were the best of the best as far as scientific thinking went, scientific thought went. That's going to be in England. Others that are going to be created, one in Naples, France, by Louis XIV. He's our master of absolutism. Louis XIV is he's the grandson of Henry IV. Prussia, Frederick I, we'll talk about that guy. He's going to create one. In Russia, Peter the Great, pretty great, or maybe not, we'll find out. That'll be a guy we talked about, is also going to create a scientific society. And all those guys, kind of interestingly enough, are all absolute leaders, so they want to increase their power, increase the prestige of their state. How do we do that? Any way possible. Any way possible. Again, guys, I'm sorry if I'm going through too fast for the people who handwrite their notes. I'm sitting in a room by myself, so it's kind of awkward to stop and sit in silence. Some consequences of the scientific revolution, some big outcomes. So first, and I would star this, because this will be something that we talk about after we talk about kind of the style of governments that we're going to see in Europe after 1648. So The scientific revolution leads to the Enlightenment. We start questioning the state of the world and medicine and the state of the universe. Now let's apply those questions to the state of man. Now let's apply those questions to what is man's status? What is kind of the purpose of man, the place of man? Let's apply those questions to government. Let's apply those questions to anything else that we kind of haven't touched. So let's almost take the scientific revolution. We've been improving science. Now let's improve the state for people. So the Enlightenment is where you have your big philosophers who are like, let's make a difference. Let's do something about it. Better exploration, better and easier navigation. So especially with like your chronometers, with your other new navigational tools, it's easier to navigate. You can get to places quicker. You can get to them, kind of safer. You have a little bit more confidence in becoming safe or getting to a location safe. So that's nice for sure, without like sailing in the open sea and hoping you don't get lost. Acceleration of the agricultural revolution, y'all. So think about even just like Paracelsus thinking like, okay, chemical imbalance, like we need chemical treatment. That's going to kind of get us to the point where we're like, with agriculture, we realize there's certain minerals, chemicals in the soil, and if it's lacking, maybe this thing doesn't grow well. If it's in abundance, wow, it really does grow well. So it kind of gets us thinking about how we need to kind of treat the soil and how we can improve farming and improve output by bettering what we're growing in. It's also going to be something, as we're inventing new things to experiment, we're also thinking about what are some tools that we can better agriculturally produce with, right? So what are some basic things? And it's going to be out of the agricultural revolution that the industrial revolution arises. Better medical knowledge, all that could not be more huge. Because remember, like we said, like people are dying of like pretty lousy things like leg boils and ear infections and things that people like just should not die from. We hear that today and it's absurd. Someone dies of an ear infection or dies of a leg boil or something really odd. We're going to start seeing this medical knowledge and this knowledge about the human body actually taken and used. And so in the 1900s, or 1700s, 1800s, 1900s, we see this kind of medical revolution begin. And I think it's, realized in the 1900s, where we actually see massive strides toward modern medicine. Because even in like the 1900s, up into World War I, World War II, it was kind of like, for those guys, if you got injured, if something terrible happened, like, you kind of just did what you did. Like, even at like the, hospitals, it was like, well, if somebody's this far gone, we can't really help them. But today we know it's very different, but this kind of sparks that, right? We want to better understand what's going on with the human body so we can better treat the human body. Finally, number 5, y'all, finally, let's not keep writing people off as witches. So what we're going to see is, as we have more and more answers for things, as we're like, hey, it's not 4 humors, it actually is like something wrong with this part of the body or this organ that person knew. They knew that, or they guessed that, and they treated that. So they're not a witch. They just kind of used reason. And so a lot of witch hunts are going to decrease. The kind of persecution of so-called witches decrease, because scientific revolution is like, hey guys, let's use a little logic, use a little reason. There's no such thing as witches. That would have been good to know when we threw all those people in the water and hoped they floated, but, teach their own. You also see that science, religion, science, religion, not really in major conflict at this time. It's going to be more of a conflict in the 18th, 19th centuries. Because remember, everybody at this point in time is kind of a hardcore Christian. Nobody is stepped away from the church, right? They've maybe changed churches, switched denominations, but all these guys would identify as Christians. And all these guys would identify as, like, following God. And so when they're studying something, just like your Christian humanists, just like your reformers, they're not trying to topple the church. They're trying to study God's creation, right? They're trying to just find answers in God's creation. And so that's where you're going to see, the church becomes a little upset, because they're like, well, we don't see you doing that. But at the same time, the church isn't really upset, I guess, for that long. The church is going to kind of come to adopt these beliefs and be like, oh, okay, they're right. Okay, it wasn't that big of a deal. And these guys also aren't thinking about a world that exists without God, which is fairly common belief today. Whereas, 1600s, it just wasn't, right? I mean, there was no taking God out of the picture, and so they don't see themselves as doing that. What you'll see is some of these guys are kind of thinking, well, what's the origin of the universe? And that's not to say like, oh, was it the Big Bang Theory? They're not really thinking that yet. These guys are thinking, well, how did God create us? Like, how did it come about? Like, they're thinking back to Genesis, and they're like, well, when God says, like, create stuff and says, let there be this and this and this, and it's created, they're like, well, how does that happen? So they're not, again, questioning God. They're more like, how did he do this? How do we find the why or the how behind it? And then that kind of begs the question, how involved is God in his creation? So when they're starting to realize certain things and realize that the body does certain things and this does certain things, is God involved in creation, or did he just kind of make everything so that it runs on its own? And that's what a lot of people, a lot of these philosophers and these scientific thinkers kind of start believing. And they're like, well, it seems like God like created everything, and because he's God, like he kind of thought of everything and made it work the way he wanted it to work. What we'll see is it actually kind of switches on like who is all about the scientific revolution and who's not. So remember, the Catholic Church at first was like kind of cool with the scientific revolution. They're like, yeah, sometimes we mess up, so we get it. And the Protestant leaders like Martin Luther, John Calvin are like, nope, 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 nope. It's wrong. It's can't be right. You guys are not cool for studying this stuff. It's dumb. It kind of switches. So like at first the Catholics are, kind of sympathetic toward it, and then they're like, nope, science isn't cool. We don't like science. You guys are trying to challenge the church. We were wrong. You are trying to bring down the church. Catholics have become a little bit defensive. Like, think about Catholic Reformation, the fact that kind of our strategy to like reimpose Catholicism didn't really work. Whereas your Protestant nations kind of getting through it, doing better, and they're accepting the scientific revolution, and they're the ones who are kind of leading the way in the scientific revolution, like England, right? We're setting up societies, and so we kind of come to embrace it. But remember, England being Anglican, that's probably a little more moderate than like your hardcore Calvinists, right? Like your Puritans, like your John Calvins, or your hardcore Lutherans like Martin Luther. But we will see that the Protestant countries are a little more likely to embrace the scientific revolution. And that's maybe because in the Protestant countries, it was like kind of the separation of church and state. So the state leaders would accept the scientific revolution. The last thing we're going to talk about is alchemy and astrology. That's one of my favorite things because it's kind of like what starts everything up. So like alchemy, y'all, almost like the medieval form of chemistry. And the reason this starts up, the reason like scientific thinkers start experimenting with like different chemicals and whatnots, is because they were looking for a way to synthesize or a way to create gold. How do we create gold? That'd be super cool. Well, you can't. So they found that out fairly quickly, but that opens the door to creating more stuff, right? And kind of working with other chemicals and other things to create new stuff. Another thing they were doing, in addition to trying to like synthesize gold, was finding some sort of like elixir of youth. So that's actually what the Spanish were like looking for in St. Augustine, Florida. And turns out the fountain of youth did not keep you young forever, and so they're kind of still like it's a downer by that. And so they're like, we can make one. Well, yeah, no, you can't. So maybe the way it starts off, the way the study of alchemy kind of begins, is a little far-fetched and a little silly, but it's going to be huge as far as leading the way into chemistry. And by, the 1800s, we kind of start to realize, like, okay, well, let's just kind of move this into chemistry. Let's create this, and kind of chemistry is almost seen as like the more serious thing, right? Whereas 17th century, 18th century, there's not really a line between alchemy and chemistry. It's just kind of like you're playing with chemicals, you're just kind of making stuff. So it would have been seen as kind of the same in that regard. Garrison, I know you probably don't have this, but we're moving to the next slide. Paracelsus would have kind of used what he would call like magic in science in interesting ways that science today would be like, yeah, you can't do that. So magic being a very loose term, it could be something that he maybe saw as magic. It could be something that like some sort of like magic man did to heal somebody, and so he's using that and trying to create some sort of drug out of that. Cardano, he is a guy that was pretty huge. We didn't really talk about because he's not that big as far as, but he's huge in algebra. Doesn't create algebra because that's the Ottoman Empire. But he's going to be big in alchemy. Brahe, Kepler, both big in alchemy. Brahe has a lab to actually study alchemy. Same thing with Isaac Newton. Like, gravity is like his bread and butter, but he actually liked alchemy more. He was more interested in that. So how I would kind of like write this slide out is I would just write these guys' names and be like, all these thinkers are going to be big in this thing right here, in this study right here. So I'll give y'all just a couple of seconds to kind of jot that down. Alright, so astrology, if you remember from that video yesterday, I thought that thing was pretty funny. A lot of these guys who are studying the stars and studying space are also acting as astrologers to these really grand kings and queens, and it's interesting that already, like today, this is of course true, like that there's the belief that kind of the stars hold some sort of power or like some ability to, show your future, whatever else. Like that was a belief held back then, right? Because you saw the world or you saw the universe, this like space around you, those were the heavens. And so kind of for people, it's the reasoning, of course, the heavens hold the answers to everything. That just kind of almost went without saying for these people. It's the heavens, of course. And so a lot of these leaders, Elizabeth I, she had paid astrologers. Cardano, that guy big behind algebra, is going to give horoscopes for Edward VI of England. So even Edward VI, who would have been very much a Puritan, is getting horoscopes made out for him. So that's when the Puritans kind of, I think, going a little far off for the Puritans. Brahe is the court astrologer for Denmark. Kepler, court astrologer for the Austrian Habsburgs. Galileo, he gave horoscopes to the Medici family, and of course that one guy, he's like, "You're gonna have a great life." And that guy's probably thinking like, "Yes, awesome." And then 22 days later, he dies. Like, come on, Galileo, you gotta do better. I wonder like how he would have written that off as. Like, how do you be like, how are you gonna say, "Oh, my bad, like I read it wrong," or he just messed something up? Like, how do you kind of justify that and fix that? What we'll see is after the Enlightenment, during the Enlightenment, astrology kind of like decreases because it's more the idea that like man controls his destiny. And it's not so much like destined in the stars. We will see that like people still use astrology today, whether seriously or just kind of for fun. Remember I told you, I think it was the first day of school, horoscopes, garbage, because the only way to know about yourself is draw a pig, right? Everybody's like, right, I can feel it. Everyone in the classroom's agreeing with me right now. No! I always do this, guys. Always do this. To kind of finish up, I really thought it had a 4. To kind of finish up, thinking about kind of the stars and thinking about, beliefs around the stars, for peasants, I mean, the universe is very important in the sense that, again, like I said, that's the heavens. And so if it's the heavens is, controlled by what's a divine force or maybe a demonic force at work against that divine force. Maybe Satan against work or at work against God. But very much everyone saw, everything in the world, people, the world itself, the universe was very interconnected, and it was interconnected with religion. And all of these things, kind of the cool thing about the scientific revolution is all of these things do exist together. And it's not an attempt to undermine one thing or another, but it's coexisting with religion. It's coexisting with magic or all these other beliefs. So kind of cool. It is actually because there's still this belief in magic that witch hunts go into the 17th century. So that's kind of a downer there, but can't win them all. Meant to tell you this, on the AP test last year, they actually called Isaac Newton, they called this guy right here a wizard, because that's what some people would believe about these scientific thinkers. They're wizards. That's how they're discovering these things. And People were kind of amazed by them, that they made these discoveries, and so that's why they thought that. And so as the scientific revolution ends, so does the time of the, like, quote unquote wizards. Kind of a weird way to describe them, but maybe not so weird in the 1600s, right? All right, y'all. So the last thing we are going to do is make a little graphic organizer. So if you guys will use that blue sheet of paper, and you can just go ahead and start like writing this down. So if I can get through this, what we're going to basically wrap up is the scientific revolution. So I would put that, at the top of your page. When is it happening? 16th, 17th, 18th centuries, right? 16th, 17th, 18th centuries. So 1500s to 1700s. And then it kind of gives way to the Enlightenment. What you're going to see is the scientific revolution. It's really kind of a situation where you're going from the thought of the church to reason and scientific observation. So remember, where'd all your answers come from? They come from either the church, or they come from either ancient Rome, Greece. They're ancient in their answers. So if they're coming from Rome, it's all these Roman philosophers, maybe like Galen. If they're coming from Greece, that's going to be like Aristotle. The church, you defer to the Bible, right? So who's answering the questions? Who is providing the answers for us? And that's going to be, a hot topic, right? So is it the church or is it this? Should we look at reason and scientific observation? And that's what defines and characterizes the scientific revolution. We find our answers through reason, through logic, through scientific observation. That's what's changing, is who's answering the questions that we have. So moving on from this like top little section, 5 big theories and discoveries being made. All right, 5 big theories and discoveries being made. So I would just jot this down. First and foremost, you've got Nicholas Copernicus. He's actually from Poland, y'all's favorite place and book, I'm sure. And he's going to be coming up with the heliocentric theory. So as he's studying the universe, remember, he's kind of the first guy to look at this and review it. He realized it's not the Earth at the center of the universe. The Earth is not at the center of the universe. Rather, the Earth is one of several planets that rotates around a sun, right? So the sun is at the center of the universe, a heliocentric universe. Gotta draw another planet, right? Throw that down on there and give it a nice little orbit. Should we go for one more? Yes, we should. You don't have to do that many. You can just do the Earth if you want. So what we're going to say is that he says it's not a geocentric universe. We live in a heliocentric universe where the sun is at the center. Johann Kepler is going to be doing scientific observation. He's going to be observing the universe, the space around him, the planets, and he says this, you guys, it's true. We are in a heliocentric universe. So he believed it, but he had a little something to tweak about this heliocentric theory of Nicholas Copernicus. He said the orbits are a little bit off, so the orbits are not perfect circles. The orbits aren't perfect circles. They're a little bit different. So he said that after his observation, he saw that planets move in an elliptical orbit. All right, they move in ellipses or oval-shaped orbits. So it doesn't look necessarily like that. It looks a little more like this. All right, so planets move in kind of oval-shaped orbits. So they move in ellipses. It looks more like that, right? Not these perfect circles. All right, so Galileo, he's of course known for his telescope. and he is actually from Italy. He does the same thing. He's using his telescope, and he's like, guys, it's true, right? Scientific observation, it showed me it was true. So, he's sitting here and chilling with his telescope. Man, worst telescope I've ever drawn. Though I haven't drawn that many, so we'll throw some stars in there. He's looking up, and he's like, wow! The sun is at the center of the universe. These guys are right. That is the real deal. So another guy kind of coming out with that and kind of catching the heat for that, as you remember. Isaac Newton, he's going to be a physicist, so he is more interested in kind of the way things work in the world. And so he thought, if you're sitting here, you drop a ball, well, it falls to the earth. What's the why? And what we're going to see is true is that it used to be the belief, it's a terrible arrow, it used to be the belief that there are different rules for gravity on Earth than there were for gravity in space. So there's different rules that apply. We'll draw some stars. And he says, no, that's just not true, right? Gravity is universal, right? There's no different rules for different spheres or different places, right? So gravity is universal. If I drop a ball, it falls to the ground, right? And we can't write off space as having no gravity, as the rules just not existing or being just totally different. It's just a different situation. Rules stay the same always. So drop a ball, falls to the ground. Got to give him an apple, because that's supposedly how he thought about gravity, how he started thinking about that. So these guys, like I'm writing over here, astronomers or physicists. William Harvey is not. He's more concerned with medicine, right? He is a doctor. And so remember, he's the guy who's talking about the circulation of blood. And so he's like, people, everyone has a heart. And everybody's like, yeah, Will, we knew that. He's like, well, here's something you didn't know, is that heart has a very important job. That heart pumps blood throughout the body. And is very much a basis of human health. And so remember, that changes the way that doctors are going to look at and the way that doctors are going to treat the human body and treat humans. So humans have a heart that pumps blood, right? Pumps blood throughout the body. And this is going to change the way that we look at and the way that we treat the human body. Right? So that's huge in that regard. How do we look at human health? William Harvey's a big, big name behind that. Very, very important behind that. So that's kind of 5 main guys. That's not to say that they are the, only guys or, the most important guys, but it gives you kind of an overview of what's being studied, what's being talked about. And so take a look over here on this left-hand side, and we'll write this out, or you guys can start kind of writing this out. It doesn't have to be on your left-hand side, just wherever maybe you have some room on your paper. Importance or outcomes. So this emphasis on reason, this emphasis on logic, right? That's Descartes' thing. You've got to think about things logically. You've got to go step by step and answer some questions. And this emphasis on this scientific and systematic observation of nature. So in the same way that you use logic for kind of the spiritual realm, you observe nature, right, in a systematic way. So you go through certain steps, and that's kind of where we see the creation of the scientific method, right? You're going through steps to answer a question, to figure something out. You're observing, hypothesizing, doing the experiment, and kind of coming to a conclusion. And then you've got this just great expansion of scientific knowledge, y'all. This is huge, right? So this is a big, big change in how we see the world. And I think we started that on Tuesday. Like, how do we view the world? And it's a more accurate view of the world, of the universe, of the human body. And so we can understand it a little bit better. You can see this thing on the right, running out of time. So how do we understand science, space, the human body much more accurate? And so at the end of the day, what happens is the importance of the church in answering questions, it decreases. But the importance of science and reason in answering questions, that's going to be the increase. So that goes up. All right, hopefully y'all enjoyed that. It was pre-recorded on Screencastify, and so it didn't really save out. I will see y'all on Wednesday. Make sure you are ready to kind of participate in the DBQ workshop, and have a great